Hello again. So this is a presentation of the hot pulse feature. So I am not a hot pulse expert. Alex Zuravlev, who is our hot pulse expert, could not make it to Paris and attend that, so I am doing this presentation. And so may you have any questions? I can try to answer. There is also Andreas Dölger in the room. So at the end of the presentation, we will try to answer questions for you. There will be 2 quiz in this presentation. No, I'm just kidding. No quiz. You can relax. And yeah, so let's get started. So what are hot pulse? Hot pulse is an automatic tiering system for luster. This is a trendy topic these days. It is managing data placement between standard and fast luster components. This is part of the DDN Exascaler product. So I'm not going to detail every feature in the DDN Exascaler product. We are going to focus only on hot pulse and show you how it makes use of different interesting luster features. Hot pulse automatically manages flash OST pulse. It allows workflows to be transparently moved to utilize flash tiers. There is no special programming modifications required for your applications to use that. So the purpose is to reduce overall disk storage system load by offloading high I/O demanding applications and processes to flash tiers. It also manages flash tiers to avoid running out of space, and it automatically spills over to spill pulse to disk if needed. So there is this diagram to give a rough idea of how hot pulse work. So basically, your application initially lands on your flash tier, and then data is mirrored, is moved to disk tiers. So you can imagine that your application is handling files that are stored, that are residing on your flash tier, and there are internal scanners on MDT and OST devices that are analyzing file accesses and then mirroring those files to disk tiers in the backend and in the background, sorry. And you can obviously do the other way around and on demand mirror back your files from the disk pool to the flash pool. So hot pulse basically relies on 2 main luster features. The first one is progress file layout, and the second one is file level redundancy. So we are using PFL to write files, initially write files to flash pools, given that it's possible that you can configure PFL to write very large files directly to your disk pool. And then hot pulse relies on two tools. The first one is called Lamigo. It runs on MDS side, and its role is to actively mirror new files. So there is one Lamigo instance per MDT. Lamigo starts by scanning the MDT devices, and then it consumes luster changelog. So at this point, it's a changelog consumer to follow which files are new and which files are modified. And it waits for files to be inactive, and then it triggers file mirroring, basically like you would do with LFS mirror commands, to mirror files from the flash pool to the disk pool. The other tool on which hot pulse relies is called LPurge, and its role is to monitor flash OSTs, to purge old files. So there are one lpurge instance per flash OST. It periodically scans your OST flash devices for unused files. And so this scan is made at a very low level so that it's cheap and efficient at the same time. The purpose is to maintain a list of the oldest files on those pools and then to purge those pools because they are precious. They have limited space but high bandwidth and IOPS capacity. So the purpose is to purge those files when space is needed, but it's also possible to quickly release space on demand. So we've been working on newer enhancements to the hot pulse feature. The first one is called active IO tracking. So basically you have this capability inside Lustre for OSTs to be able to log every access that is being done. And it's an in-memory circular buffer of all IO accesses as seen by the OSTs. And Lamigo is able to collect and aggregate those IO logs per file. So only a fraction of data is read by the server, and only a list of most frequently accessed files is updated. So we are building this history table of files that are associated with a hit, and basically this hit would increase if a file is accessed frequently, and if the file is left untouched, then the hit will slowly decrease. So this is useful for a number of optimizations. For instance, if you have a file that is on your flash pool and that is hot, then there is no point in trying to and spending time mirroring this file to the disk pool. That would be a waste of resources because we know that this file is actively being accessed, so it is kept on the flash pool only and not mirrored. And conversely, you can have a file that has been mirrored to your disk pool, and then for any reason it becomes hotter. And then in this case, you could imagine that it would be nice, in order to improve the application's performance, to automatically mirror back this file to your flash pool. And so this is a newer feature. It's still disabled, and because there are still some work needed on the fine-tuning and find the best, let's say, parameters to decide which files to mirror back automatically. The other new feature is called pool spilling. So it means that for every OST pool, you can define a spill pool. And the use case is if you have a flash that is filling up faster than it drains, then you would want to avoid creating new files on this flash pool. So if you are defining PFL so that your new files are created on the flash pool, and then this flash pool becomes full, then you would get space errors for applications that are trying to create new files. So the spill pool mechanism avoids this problem by detecting that the initial pool is full, and then automatically and directly creates the new file on the spill pool. So it releases pressure on the full pool, and at the same time, it throttles down write speed, but this is to avoid running out of space, obviously. This can be configured with two tuning parameters. The first one is to define which spill pool you want to use for a given pool, and the second one is the threshold percentage, so it means at which point you want to get full before spinning over to a different pool. And you can chain spill pools so that we support up to 10 spill pools and not an infinite number to avoid infinite loops. Okay, another enhancement that is beneficial for Lamigo is to support rules. So Lamigo is the tool that automatically mirrors files from your flash pool to your disk pool, and it does that for every file. There is no distinction. And policies let you refine this behavior, so you can define filters which will decide which files will be actually mirrored. And you can define filters on a number of attributes, of course POSIX attributes like file size, timestamps, owners, file names, extensions, also extended attributes like HSM and LSOM, so internal luster attributes, and any regular extended attribute in the name value format. A number of improvements have also been made to improve file mirroring. Initially, it was not possible for Lamigo to run on a pre-existing file system. So now Lamigo can run on such a system, so it's very useful if you have an already existing file system and then you decide to enable hot pools. So in this case, there will be a scan of the whole metadata devices. This is required because in such a case, there are no pre-existing changelog records for the files that were already there on the file system. And it's also useful if you have lost some changelog records. It's possible because changelog are consuming space on your MDT devices, right? So you could run out of space, and then that would mean clearing some oldest changelog records, or there could be errors in the changelogs. So thanks to this scanning capability, it's possible to use Lamigo on already existing file systems. And there is also the name changelog user and a per user changelog mask that is new to Luster, and it simplifies automatic registration and minimizes overhead at the same time. Another enhancement is the possibility to know the rotational status of a given pool. So it means, are you defining a pool that that consists in disks or in NVMEs, in SSDs? So it's possible for Luster to report this status. If you define a pool, then you can have access to the information, whether it's based on rotational or non-rotational storage. And more importantly, the client would automatically prefer the pools that are non-rotational. Of course, it doesn't mean that, so you can still use the prefer flag on your pools, but this feature avoids you to have to set this prefer flag on every OST pool. Okay, so I just want to present a small testing we've made. This is on this configuration. We have obviously one flash pool on NVMe and one disk pool that is using rotational disks. If we write directly to the NVMe storage at the backend level, we have a performance of around 15 gigabytes per second. And if we write directly to the disk storage, we have, so rotational storage, we have around 10 gigabytes per second. And the test consists in running IOR in a loop from 2 clients. And here's what happens on Luster. So on the left-hand side, you have what is called the performance pool. So this is the flash pool. And on the right-hand side, you have the capacity pool. So it's larger and it's made of disk pools, rotational pool. And you can see the right pikes in yellow that correspond to IOR running in a loop. And if you have a closer look, you can see smaller green peaks. So these are read. This is a read activity. Obviously, it's not made by the application itself. This is the result of Lamigo activity, that is analyzing the files being accessed and mirroring in the background those files from the flash pool to the disk pool. So you can see the corresponding write peaks on the capacity pool on the left, on the right, and so this is happening in the background during the time the application runs. And at the bottom, you can see that capacity is filling up progressively on the flash pool and on the disk pool. So what are the use cases we see for hot pools? The first use case is very useful in HPC applications. So I'm talking about the applications that are designed according to the checkpoint restart model. In this model, your application is going to compute for a certain amount of time that is usually fixed. After this time, the application will proceed to checkpoint, which consists basically in flushing its memory down to disk. And after that, it will resume computation for the next cycle. And obviously, while the application is checkpointing, it is not computing, so it could be considered a waste of resources regarding the computation resource in the cluster. So the purpose is to reduce as much as possible the time taken by the checkpoint step. So if you consider this, you can imagine that the application that is going to checkpoint will do on the flash pool, so as quickly as possible. And then once computation resumes in the background, while the file system is not used by the application, then hot pools will proceed to mirroring to the disk pool in order to release pressure on the flash pool. The other use case is that with this feature, we have virtually infinite flash capacity. If you consider that an application uses files for some time and then they are barely accessed again, it means that your application will always use files, create new files, and use them when they are on the flash pool. And then once they are moved, they are mirrored, to the disk pool, they are barely accessed. And the third use case is obviously backup, because this mirroring capability means we are making multiple copies of the same files on more economical storage. So that can be seen as a backup capability. So at the beginning of this presentation, I told you that hot pools is a DDN exascalar specific feature, but it relies on a number of Lustre features that are already available in the code. For instance, the pool spinning feature is available from Lustre 2.15, as well as the name changelog and user and per user mask. Regarding rotational status, from Lustre 2.13, OST pools are already reporting their rotational status. And in Lustre 2.15 was introduced, the capability for Lustre clients to automatically prefer the non-rotational pools. And the I/O access log capability has been here from Lustre 2.14. So this is the ability for OSTs to log every I/O accesses that are carried out. And that's all for this presentation. Sorry again, no quiz. Do you have any questions?
Thank you, Sébastien. Questions for Sébastien?
Can you pin the project on the hot pools, for example?
Sorry? You want to see that slide?
No, my question is, for example, we have a lot of different projects.
Yep.
Can you pin specific projects on the hot pool?
You mean so filter depending on the project ID?
Yes.
I guess so. Yeah.
Thanks.
The first line. Okay.
Well,
Maybe
one
you
second,
can give
Nicolas.
the mic to Andres.
So, yeah, the example here, it does filter out specific project IDs from being purged from the hot pool. right? So there's, you can do it as a general policy, but there's also a command LFS pin that, oh no, that's for PCC, never mind. Sorry. There's the capability that we might write in the future.
I guess using the file name filter, you can always end up achieving what you suggest.
Another question.
LPurge was mentioned as the tool to purge old data from the flash pool, but could the same tool also be used for the disk pools to get rid of data which hasn't been accessed for, let's say, a year?
Yeah, I don't see any good reason why not to do that, but I cannot see any good reason why to use this tool. I don't know. If maybe, yeah, if you need something efficient, why not?
Yeah, my question is basically, is it super specialized to just work on Flash, or is it so generic that you can use it on any pool you want?
Well, maybe Andreas.
Yeah, no, the policies are only based on the pool names. It doesn't know anything about, you know, this is Flash per se, yeah. Right? But at the same time, the only thing that LPurge does is it just releases the mirror from the Flash pool and keeps the mirror on the disk pool. It doesn't actually delete the files or anything. So you would probably just be better off having a tool that does a find or whatever and then deletes the files, right? I don't personally like, you know, having automated tools delete files. So, you know, that's something that usually is done, you know, by multi-step process, sending, you know, confirmation to users and things like that.
Again?
Yep, it's me again. So have you heard about production experiences from using hot pools? You mentioned that there are a few features which are still quite fresh. Have you heard any experiences from the field?
I don't have personally. I don't know
Somebody
if
from
Andreas
DDN?
has some feedback that can be shared.
Yeah, so there's, you know, I wouldn't know. I mean, there's, you know, 20 or 30 sites that are using hot pools at least. And so it's generally, you know, in pretty good shape now. You know, migration from disk back to flash, that's the main newish feature. I haven't heard particularly bad stories about it. It's hard to know for sure. I think you know, many pools are set up so that, you know, the main working set stays on flash. And if they're accessed commonly enough, you know, they just never leave flash, right? Because we only release space when the pool gets above a certain fullness threshold. So we can do the mirroring in advance and then only release the space when it's needed. And so if the pool doesn't get too full, you know, and only old files are falling off the end and they don't get used very often, so that feature doesn't get used as much. But, you know, there have been, you know, I'll admit, there have been issues with hot pools, mainly related to, you know, processing change logs and things like that. And then, you know, the agents stop doing the mirroring and things like that.
The only thing to add is this has been from early versions like about 18 months or 2 years. It's been around, so it's not new by any stretch. Another question?
We do have a big problem with going from cold to hot pool, part of the hot pooling, which frequently trashes shared libraries, for instance, or singularity containers. We have a DDN support case for that, but there's no progress. Turning off the heat function in hot pool removes the problem. Immediately when we turn it on, we get problems with shared libraries on some clients being trashed and on other clients at the same time being perfectly okay. something we really would like to get sorted, but we haven't been able to get a trigger for it. But we need to look into that again sometime.
Thank you. Any question online?
Yes. If we lose the pools, can I/O be gracefully redirected to the disks?
I'm not sure. I mean, this is based on the PFL mechanism, so.
Yeah, so the question was, if we lose the flash pool, can the I/O go to the disk pool? And that's a functionality unrelated to hot pools, more related to the file level redundancy. And so if FLR, if the OST is offline, it will try to pick the mirror copy of a file that's on available OSTs, and so that is working, but we don't necessarily, hot pools is more of a caching mechanism, it's less of a redundancy mechanism, and so not necessarily all files will have a flash and a disk mirror, right? So if newer files are more likely to have two copies of the file, and so it can improve the redundancy, and especially for like checkpoint restart, you're very likely to have two copies of the file as long as the restart is in a long enough time after the original copy was written that you would have the mirror copy created. Usually the delay is about 10 minutes by default, and so after 10 minutes you would have two copies, and if OSTs go offline, you would actually have increased availability of the data, which is good for the restart part.
Thank you. Okay, thank you, Sébastien.
Sure.
Last question. Sorry. Not yet.
We have one of those, no, we have two actually of those SFA18 case, and we have 4 metadata servers. Could this hot pool functionality be added to our DDN system, or do we need to buy a new one to have this functionality?
So which version you said?
We have the SFA18K
Yeah, but the
with
software stack?
with embedded OSSs and the exascaler. I don't know. I don't remember the exascaler version, but
At least what I can say is that thanks to the scanning capability, where is it? Anyway, thanks to the new capability for Lamigo to be able to scan on already existing MDT, then I guess at least this does not prevent you from using hot pools on an already existing file system. Yeah.
and it
So why not?
wouldn't conflict with the if we already are using PFL, will it conflict somewhat? No. Thanks.
Thank you.